Let's talk about inertia. So a little history before I give you the definition and explain what inertia is. A long time ago, there was this guy named Aristotle. Now, this was around the year 330 BC, which was 2,350 years ago. So this is a long time ago. So Aristotle said that the natural state for things in the universe was to come to rest. Now, the thing about Aristotle is that he was a really smart guy, especially for his time. However, because this was so long ago, he was wrong about a lot of things. We've kind of learned a lot more in that time since then. But Aristotle and everyone around him back then thought the natural state for things in the universe was to come to rest because they always observed things to come to rest. So, take for instance this soccer ball that's in the picture on the slide. If you kicked that soccer ball, what would happen to it? Well, it would roll for a little while and then it would eventually slow down and stop. So that's why people thought the natural state for things in the universe was to come to rest. They thought that a constant force had to be applied in order for that object to continue its motion. Well, now, these days, we know that the reason the soccer ball comes to rest is because there is a force called friction, which is slowing it down and making it stop when it's moving. So the question is, what is the natural state of objects if they're moving? If there's no friction happening, what would the natural state of an object that's moving be? Would it come to rest or would it continue moving? So enter Galileo. This is in the 1600s, so quite a while later. And he did this thought experiment with ramps and this rolling object that was made of metal. Okay, I want to show you a video. So basically what his thought experiment was is that he had this ramp right here and he saw that this metal ball right here, if you let it go at that height, it would roll up to the same height. So when you have a steep angle like this, he saw that the ball will roll a small distance to attain that original height that it had before. Now, what he did next was that he actually kind of elongated that ramp so that the opposing incline is reduced. So you can see here that the ball has to roll farther in order to attain the original height. So he saw that though that ball was still attaining the original height, even when he elongated that ramp even more. So his question was, what happens if the opposing incline is not inclined at all? So his thought experiment, obviously he did the beginning of this experiment, but the part that what we call a thought experiment, which means basically you just think about what would happen, you don't actually do it because sometimes these experiments are impossible. We'll talk about Newton's thought experiment later. But he thought, okay, what would happen if I just dropped that incline? The ball wants to go up to its original height, right? That's what he had observed before. But because there's no original height, theoretically, the ball would never stop. It would roll forever if friction was absent. So, what Galileo said then, after he observed that and he did his thought experiment, he said that it's the nature of an object to continue its state of motion, whether that be to continue at rest or continue in motion. Okay, so if an object is at rest, it will stay at rest. If an object is in motion, it will stay in motion. So he had this idea and he came up with a term for it. It's called inertia. Now, the definition of inertia is an object's resistance to a change in its motion. So, like he observed with those balls that are just rolling along into infinity forever if friction was absent, they have a resistance to their change in motion if they are in motion. Similar to if something is at rest, so for example, if something's sitting at rest in front of you on your desk, that object is at rest, it's going to stay at rest. It has a resistance to a change in its motion. Okay, so this is the idea behind inertia. Now, we've all probably heard this term before, especially if you've watched Bill Nye, which I hope you have because I love Bill Nye. And if you remember the theme song in Bill Nye, inertia is mentioned. Anyone remember how the theme song goes? Bill, 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 Bill Nye the Science Guy. And then there's a woman that says, inertia is a property of matter. Now, what is matter? Okay. Matter is just mass, which is just basically the amount of stuff something is made of. Now, I like to tell a corny joke here that, you all have mass. We all have mass, right? Mass is just the amount of stuff that our body's made up of. And because you all have mass, you matter. Aw. I love my corny joke. I know you guys all hate it, but it's okay. So matter is mass, okay? And because inertia is a property of matter, the amount of inertia something has depends on the amount of matter or mass that object has. Okay, so the more mass something has, the more inertia it has, the more resistance it has to a change in its motion. So let's think of an example. So again, the definition of inertia is an object's resistance to a change in its motion. So if I have a little tiny pebble, that little tiny pebble is very, very, very small. It doesn't have a lot of mass. It doesn't have a lot of matter. So it doesn't have a lot of inertia. And it doesn't have a lot of resistance to a change in its motion. Meaning, if I just kick that pebble, it's not going to be hard, right? There's not a lot of resistance to my change in its motion. Now, on the other hand, if there's a huge boulder at rest, that huge boulder is very, very massive, right? There's a lot of mass. There's a lot of matter there. There's a lot of inertia. So because there's a lot of inertia, it has a lot of resistance to a change in its motion. So if I tried to push this boulder over, do you think I would be able to do it? I mean, I'm pretty strong, but I won't be able to do it, okay? Because it has a lot of inertia. It has a lot of resistance to a change in its motion. Another example is if that boulder were moving. So we did a couple examples of something at rest. This is an example of something in motion. That boulder, again, has a lot of mass. It has a lot of inertia. It has a lot of resistance to a change in its motion. And right now, that motion is coming toward Indiana Jones looking to squish him. Okay. And Indiana Jones runs away because he's not going to turn around and try to stop that boulder. It has too much inertia. It has too much resistance to a change in its motion. Indiana Jones is not going to be able to change its motion. Now, on the other hand, if that huge boulder was a little tiny pebble, he would be able to just catch it and change its motion, stop it, right? But because the boulder has more inertia than the pebble does, it has more resistance to a change in its motion, he runs away instead, which I would as well. Now, other examples of inertia, here's another example here. Now, notice how the car is moving, right? And when it stops, all of a sudden, all those people keep moving the way the car was before. So this is an example of inertia. And the reason for that is those people are moving with the car. Now, because they have inertia, they have mass, they have a resistance to a change in their motion. So when the car slams on its brakes, they keep moving forward. And you've probably experienced this before if someone who's driving a car and you're in the car with them, or maybe you're driving, and you slam on the brakes and all of a sudden you kind of fall forward, right? It's because your body has inertia, has a resistance to a change in its motion. It wants to keep moving forward like it was before. Okay. Now, for one of your little assignments in this hyperdoc, I want you to try to think of another example of inertia. Okay, just like this car example, like this. Okay, so that's the definition of inertia, is a resistance to a change in an object's motion. And remember, the more mass something has, the more inertia it has, because inertia is a property of matter.